Hello everyone. Today we are going to discuss numerical problem related to operators in quantum mechanics. We have x and px as the coordinate and momentum operators, and we are asked to prove commutation of x px power n equals n I h bar px power n minus 1. This symbol is read as h bar or h corp, and h bar equals h by twice pi, where h is the Planck's constant. Okay, and this is also called reduced, okay, Planck's constant, and the x component of momentum in operator form can be written as minus I h bar del by del x. Now let us take the left hand side of this relation. Okay, so I'm writing, taking left hand side. So we have commutation of x px power n. Now we are asked to prove this. Okay, uh, we have px power n minus 1 on right hand side. So we can write this commutation relation in this way. Okay, so we have, let us write px and px power minus 1, and this product gives us the value okay 1. So we have this px power 1 and px power minus 1. So px power 0 is 1. Okay, so I'm writing over here px power 0 is 1. So we are using a simple mathematical tricks, and we have px power n. Okay, now let us associate these two terms. So we can write in this way. Okay, we are changing this commutation relation in this form because we have px power n minus 1 on right hand side of this relation. So we can write, let me change it. Okay, commutation of x px power n equals commutation of x, and we have px power n minus 1. So we are going to use this relation. Okay, now this px can be taken outside the commutation relation towards left hand side. Okay, and this px power n minus 1 can be taken outside the commutation bracket or relation towards right. So we can write in this way px, and we have commutation of x px power n minus 1 plus x, commutation of x px, and px power n minus 1 is taken outside the commutation bracket, and this is a standard commutation relation, and its value is I h bar. Clear? Now we can write and this way. Okay, I h bar, I'm taking this at first, and we have px power n minus 1 plus, so we have px and commutation of x px power minus 1. So let us write, okay, in this way. So I'm keeping this in a box. Now this is equation 1. Okay, this is equation 1. Now let us simplify equation 1 further. Okay, we can further simplify this equation 1 further. Okay, so we can write IH bar px power n minus 1 as it is, plus we have px and commutation x. Okay, px power n minus 1 can be written as px power minus 1, px power n minus 1, and we know this product is 1. So let us associate these two terms. So we get this, okay, px power n minus 1 and px power minus 1. So we can simply write in this way. So we can write finally px power n minus 2. Okay, so we have this. Now we can take this px outside towards left and px power n minus 2 outside towards right. So we can write commutation of x px power n equals I h bar px power n minus 1 plus, so we have px square because we have one px outside. So px square commutation x px power n minus 2 plus we have px and commutation of x px, and we can take this px towards right outside the commutation relation. So we have px power n minus 2, and this is a standard relation and its value is IH bar. Clear? Now, since these two px, that is px and px power n minus 2 are outside the commutation relation, so we can simplify and write px power n minus 2 px power 1. Okay, so this gives us value px power n minus 2 plus 1. So finally we get px power n minus 1. Okay, so we have I h bar px power n minus 1. So I'm writing this term in second. So we have I h bar, and these two on simplification gives px power n minus 1, and we have this, okay, px square commutation x px power n minus 2. So let me erase this. Okay, now we can write commutation of x px power n equals, so we can add these two terms and we get 2I h bar px power n minus 1 plus px square commutation of x px power n minus 2. So we have this. Okay, this is equation number 2. Now we can simplify equation number 2 further. Okay, we can use a simple mathematical tricks inside this commutation bracket. Okay, so now we have this commutation of x px power n equals, I'm rewriting this equation 2 over here. Okay, 2I h bar px power n minus 1 plus px square, and we have commutation x px power n minus 2. Okay, so we can write now we can write in this way. Okay, so this gives us the value 1, and we have px power n minus 2. Okay, inside the relation. So px power n minus 2 inside the commutation relation. Now, as I said earlier, okay, these two terms gives the value 1. So let us associate these two, okay. So we can write 2I h bar px power n minus 1 plus px square, and we have commutation relation, okay, x px power n minus 3. Now we can take this px outside towards left hand side and px power n minus 3 outside towards right. So we can write commutation of x px power n equals 2I h bar px power n minus 1 plus px power 3, and we have commutation of x px power n minus 3 plus px power 3, sorry, px power 2, okay, we have this px power 2, and we have commutation of x px and px power n minus 3, okay, it's taken outside towards right. Now this gives us the value I h bar and px square and px power n minus 3 gives the value px power n minus 1. So we can write commutation of x px power n equals, so 2I h bar px power n minus 1 plus, so this on simplification gives the value I h bar px power n minus 1 plus we have this term, okay. Px power 3 and commutation of x px power n minus 3. So we can write okay, so we have this. So we can proceed in this way further, okay. We can proceed in this way further. We have equation 1, equation 2, equation 3. Now let us do some rough work, okay. We have this commutation x px power n equals ni h bar px power n minus 1. So we can see the power of px, or we can compare the power of px on left hand side and on right hand side. We find power of px on right hand side is reduced by 1, and we get n on right hand side, or we have n on right hand side. Now let us start from n equals 1, okay. So we have this x px power 1 equals n is 1, so we can write I h bar px power 0. Now let us take n equals 2. So we get this, okay. Commutation of x px power 2 equals, we have n, so we can write 2 I h bar px power 2 minus 1 is 1. So we get this. Now So let me change it, okay. Let us take n equals 3. So we can write in this way, okay. Computation of x, px power 3 equals 3i h bar px power 3 minus 1. So this gives us value 2. So we find we get 1 on right hand side, and in this relation, okay, we are getting 1 on right hand side, and we have px power 0. In this relation, we have n equals 2 on right hand side, and we have px power 1. That is, power of px is reduced by 1 because power of px is 2 on left hand side. Now in this relation, we have n equals 3 on right hand side, and power of px on left hand side is 3, whereas power of px on right hand side is 2. That is, power of px is reduced by 1 because we have power 3 on left hand side for px, and power of px on right hand side is reduced by 1. That is, we are getting 2. Now let us take n equals 0, and for n equals 0 in this relation, okay, we get commutation x px power 0 equals 0. So we have this relation, okay, and this is to be noted. So we use this concept, and we need to note this. Now, so let me write over here, okay. We have x px power 0 equals 0. Clear? And we can see that power on right hand side is reduced by amount 1, and we are getting n on right hand side. So now let us take n equals 3 in equation 3. So we can write commutation of x px power 3 equals 3 I h bar px, and 3 minus 1 gives us 2 plus px power 3 commutation of x px power 3 minus 3. So this is px power 0, and this commutation, okay, relation is 0. Its value is 0. So we can write commutation of x px power 3 equals 3 I h bar px power 2. So we have n equals 3, okay. So we can see 3 on right hand side, and if we compare the power of px on left hand side and on right hand side, then we find power of px on right hand side is decreased by, or is reduced by, the amount 1. Okay, so we are getting this. Now let us come to relation or equation 2. Okay, now putting n equals 2 in equation second, okay, we get commutation of x px power 2 equals 2 I h bar px power 2 minus 1 is 1 plus px power 2 x px power 2 minus 2, okay, and we get this, okay, px power 0, and this relation gives the value 0. So we can write commutation of x px square equals to I h bar px power 1. So we are getting n equals to on right hand side, and if we compare power of px on left hand side and on right hand side, we find power of px on right hand side is reduced by the amount 1. Clear? Now let us take n equals 1 in equation in equation 1. Okay, we can write commutation x px power 1 equals, so we have this, okay, I h bar px power 0, because we have n minus 1 and we are taking n equals 1, plus px and commutation of x px power, so we have n minus 1, so we get this, okay, so this is 0, okay, this is 0. So we can write commutation of x px power 1 equals, so we have 1, so we can write simply in this way, okay, 1 I h bar px power 0. So for n equals 1, we have 1 on right hand side, and if we compare power of px on left hand side and on right hand side, then the power of px on right hand side is reduced by the amount 1. So on generalizing, okay, on generalizing, we can write commutation of x px power n equals n I h bar px power n minus 1.